Hello guys, welcome to the channel Understanding.Concepts.Of.Physics. We have been doing oscillations in some time, and if you have been following up my videos, then you might have seen that we had derived a differential equation, and then we did for acceleration, and then we came on to deriving the velocity, and today we are going to derive the displacement on linear simple harmonic motion. So let's just see quickly how to derive this displacement. A lot of things to learn over here. First of all, displacement in linear simple harmonic, in linear simple harmonic motion, if we want to derive, we are supposed to start with the equation of velocity, which we have derived in the previous video. I would really request you to get back to the previous video in order to see the derivation of this video, this equation, v is equal to omega root of a square minus x square. Now this velocity can be written as dx by dt. So velocity is nothing but derivative of displacement with respect to time, which is equal to right hand side is as it is, so that there is no change in right hand side. Now I would like to solve this differential equation. So I would want to make one variable on one side and the other variable should go on the other side. Because x is a variable, t is a variable, omega and a are constants. So x, all terms of x should be on one side and all t terms should be on the other side. So I'll take this dt on the other side. So dt goes that side. However, I cannot remove this x only, so I'll have to remove this entire root of a square minus x square. So this entire root of a square minus x square will come downstairs and dt is going to go upstairs. So I'll get dx upon root of a square minus x square, omega as it is, dt is on the numerator. Now I'm ready to integrate, so I'll integrate on both the sides. So integration on both the sides, and I'm seeing that omega is a constant, so omega comes outside. And integration of this part is again would go into a higher advanced stage of calculus, wherein you understand our integration of dx upon root of a square minus x square. How to solve this is a part of mathematics. We are not going to go deeper into how to get this, but yes, its form is sine inverse of x by a. So the equation, the solving part of this integral is sine inverse of x by a. So I'll just write directly on that part. So this is where we use mathematics as a tool to solve physics. So thanks to all the teachers of mathematics who make students understand how to get this integration to sine inverse of x by a. And then integration of dt is t, so that is as it is, and there will always be a constant of integration, that is normally we add as c, but and in the coming videos you will understand that this constant of integration is going to be a very special constant of integration. That's why we do not write this as c, we will be writing this as alpha. So this is the key steps. You can see that in this step I have used a mathematical equation. Like you can solve this if you are mathematically inclined. You need to put this x as, by using substitution method of integration, put x as equal to sine theta or cos theta, and you can just solve it by substitution method and you get this value. But as far as physics is concerned, you are not expected to derive this thing. You just have to write this equation. Then I want x, I am deriving displacement, so I'll take this sine inverse on the side. So sine inverse will become sine, everything as it is. And then I want x, I don't want a, so a was in the denominator, so now this will go in the numerator. So x would be equal to a sine of omega t plus alpha as it is. I am calling this as equation number 1 because what has happened over here is, in finding out x, we have got an unknown constant alpha in our equation. So somehow we need to know the value of alpha as well. Now, as we have discussed in the velocity video, that whenever we wish to find out the constant of integration, we use boundary conditions. So here also we'll be using boundary conditions, and let's see how it works. So for boundary conditions, boundary conditions are applicable only to variables. So x is the variable and t is the variable. So somehow by logic, if I know the values x and t, then I can easily find out the value of alpha. And once I get the value of alpha, I'll put that value again to equation number 1. So let's just quickly go into this. So now there are two conditions here. Okay, if the particle begins from the mean position and if the particle begins from extreme position. So there are two conditions, there are two cases actually. So if the particle begins from the mean position, that means the time when the time was 0, because the particle begins means the time was 0, and because it is starting at the mean position, the displacement is 0 as well. Now, so here you should understand that when the particle begins from the mean position, like when the particle is beginning from this position, center position, then the displacement is 0. So if you see, the displacement is 0 if the particle is beginning from mean position. Like you have just pushed the mass over here, or you have just when you push this mass over here, it will start to oscillate like this. So the particle has begun from the mean position. And the other case is like if the particle begins from the extreme position. So one way of starting from the positive extreme is like you pull this thing entirely to the extreme position, somewhat like this, and then you release it. As you release it, it will start to oscillate between the two extremes. So this is starting from positive extreme, that is positive A. However, you can also start from the negative A as well. How? You just have to push this spring to the negative extreme and it would look something like this, and then you remove the force so that the mass actually oscillates between the two extremes. So either you start from the mean position, or you start from the positive extreme, or you start from the negative extreme. So if you start from the mean position, x ka value is 0. If you start from the positive extreme, x ka value is plus a, and if you start from the negative extreme, then the x ka value is equal to x value is equal to minus of a. So this is what it is. Okay, so let's so now if the particle begins from the mean position, then I'll put these two values in my equation number 1. So I'll put these values in equation number 1. So I would get something like this: t is 0 and t is 0 and x is 0, and a sine omega, wherever there is a t, there is a 0 plus alpha. So if you can just check this equation, if you are able to see this, wherever there was t, there is 0, and where there is x, I have put a 0. Now as a goes this side, 0 upon a is 0, so the entirely thing goes to 0. 0 into omega is 0, so this is 0. 0 plus alpha is alpha. Now I'll check for angle. So what angle of sine will give me 0? So we all know that k sine 0 is 0, and we all know that k sine pi is also equal to 0. So because this sine alpha is equal to 0, that means this alpha can be 0 or it could be pi radians. So I have just found out the value of alpha if the particle is beginning from the mean position. Now if the particle was about to start from the extreme position, start means the time is 0 and the position is either plus a or minus a. So I'll put the values in the equation number 1. So if you can see on the screen, x is equal to a sine omega t plus alpha, as x will take the value as plus or minus a, and t will take the time ka value as 0. So now what happens here? A gets cut and you get plus or minus 1, and 0 into omega is 0, so only alpha remains, so sine alpha remains alone. Now I'll find out what values of sine will I get 1 or minus 1. So I know that sine 90 is 1 and sine 270 is minus 1, and 90 can be written as pi by 2 and 270 can be written as 3 pi by 2. Now I'm not going into detail how to convert this degrees into radians, but yes, you should be knowing this much amount of math in order to handle oscillation. So this is what alpha ka value is. Now let's just put quickly in the equation number 1 and equation number 2. So in equation number 1, so x is equal to a sine omega t plus, wherever this was alpha, I got pi by 2, and wherever there was alpha, there was 3 pi by 2. Now what is going to happen over here? X is equal to a sine omega t plus pi by 2. Now sine of omega t plus pi by 2 is giving out minus cos omega t. So here I am using that formula which is sine of theta plus pi by 2, theta is just any angle, is equal to cos minus cos theta, so this is one formula. And I can also do for this as well. Okay, sine of theta plus 3 pi by 2 gives me equal to cos theta. So this is one of the formula, other formulas. Now there is a very simple trick to do this, and many math students who are accustomed with these formulas in trigonometry will be knowing how to convert these two into these two. But then, in case if you are not inclined to mathematics, or if you have not opted for math, if you do not have a math as a subject, then I would request, then you need to by heart these two things. There is a very simple trick. I maybe in one of the videos going forward, I would especially make a basic trigonometry video, and you would really understand how to work on this. So I have showed you for how alpha ka value, if there is this pi by 2 or 3 pi by 2, what do you get. However, if the value of alpha is 0 and pi, I can just show you that as well. So if alpha ka value is 0, I have put a value of 0 where there is alpha, and I have put a value of pi wherever there was alpha. Now omega t plus 0 is omega t, so this remains as it is. This is the most easiest form. And then pi, so when it is sine theta plus pi, the formula goes minus sine theta. So I have written minus sine of omega t, wherever there is theta there was omega t. So if you see, I have got 4 formulas here. If you can see on the screen, there is this 1, there is 2, there is 3, and the 4th one. So the ideal case is like, what are you supposed to learn is, you learn the basic formula, that is x is equal to a sine omega t plus alpha, which is very much visible on the screen. So this is one of the formulas which is most important forms of oscillation, as well as to other chapters as well. Like you will see this in electromagnetic induction as well, AC circuits as well, where these equations of sine and cosines are used. So I hope you have understood this, and we have found the value of alpha as well as x, that is the displacement. In the coming videos, we are going to see something relating to maximum and minimum of each one. Each one means displacement, velocity, and acceleration, all three. So this is the next topic of the video, and hope you enjoyed this video, and just keep coming back and keep watching the videos. Subscribe the channel in case you have not done so, and keep the videos keep watching the videos from the playlist, as it will provide you a better link. Thank you so much for watching. Have a nice day. Bye.